Hi, I'm a student just like you, your peer. I'm here to share with you my learnings, challenges, tips, and tricks as I learned this concept. So, here is an intro to linear functions from me to you. At the end of this video, my goal is to help you define and identify a linear function. So, what is a linear function? A linear function is any function that is a straight line when it's graphed. This means that the line has no curves or twists. For example, this line is a linear function because it's straight and has no curves or twists. So is this line. It's a straight line with no curves or twists. What do you think about this line? Do you think that's a linear function or not? Well, it's not because it has a curve in it. What about this one? That's also not a linear function because it has a curve in it. Now, how do you identify if a function is linear or not when only looking at its equation? A simple way that I use to do this is to identify the relationship between x and y. In a linear function, a constant change in x must correspond to a constant change in y. When I first heard this, I was confused and didn't really understand. If you're feeling that way now, don't worry. Let us walk through an example step by step to understand this. Say you have a function y equals 2x plus 3. Now, how do you identify if this is linear or not? First, make an x and y table. Let's choose some values for x. Let's start simple and choose 1, 2, and 3. Now let's find the y-coordinates of those functions. To do this, substitute x in the equation and solve for y. Let us solve for x equals 1 together. To do this, write y equals 2, and instead of writing x, substitute it with the value of 1. 2 times 1 plus 3. Therefore, y equals 2 times 1 is 2, and 2 plus 3 is 5. So therefore, when x is 1, y is 5. Now it's your turn. Pause this video and solve for x equals 2 and x equals 3 and write it down in your table. Awesome! Check your values. If the values you got are the same as mine, then awesome. If not, don't worry and try again. Now we can see that when x is 1, y is 5. When x is 2, y is 7. And when x is 3, y is 9. So what does this tell us? Going back to what I said, to be a linear function, a constant change in x must correspond to a constant change in y. Let us check if this rule applies to our equation. Each time you can see that x is increasing by 1. 1, 2, 3. And let's check the y-coordinates. Each time y is increasing by 2. 5 to 7, you add 2, and 7 to 9, you add 2. This shows that y equals 2x plus 3 is a linear function because as x is increasing constantly by 1, y is also increasing constantly by 2. Now, let's try plotting these points on a graph just to visually see if this is a linear function or not. X is 1 and y is 5. X is 2, y is 7, and x is 3, y is 9. You can see that this forms a straight line that will keep going if you add more and more coordinates. Now let's try another example. Let's take the function y equals x squared. Let's first make an x and y table. Let's choose the points 1, 2, 3, and go ahead and pause this video and just like we did with the previous function, substitute the x values back into the equation and find the y coordinates. So here is the work I showed to find the y coordinates. Okay, once you're done doing that, you should get the point when x is 1, y is 1, when x is 2, y is 4, and when x is 3, y is 9. Now let's try to see if this shows a constant change in x while there's also a constant change in y. Now let's see, x is increasing by 1 each time. In the first coordinate to the second coordinate, y is increasing by 3. And in the next one, y is increasing by 5. So that shows y is not constantly increasing each time, while x is. But to be a linear function, both y and x has to constantly increase. Therefore, y equals x squared is not a linear function. Now let's also try to see this in a graph. When x is 1, y is 1. When x is 2, y is 4. And when x is 3, y is 9. Now you can see a curve function. If we were to plot all the lines of the function, it would create a line something like this. Therefore, you can see the difference on how to find a linear function. Okay, it's your turn now. Here are 4 equations for you to try to figure out if they are linear or not. 1. Y equals 4x plus 6. 2. 4x plus y equals 3. 3. Y equals x plus 4 plus x. And 4. Y equals x times x. I always tend to forget steps, and therefore like to create checklists. Here is my checklist to figure out if a function is linear or not. I hope this video was helpful. In the next video, we will continue linear functions, and I will share my learnings on the types of linear functions. Hope to see you. Thank you, and bye.